In Chile, radio telescopes are being combined into a powerful array on the ground, but telescopes have also been sent into space. By the 1970s, these telescopes could also observe light in the ultraviolet and infrared range. The ESO is headquartered just outside Munich. For astrophysicist Susanna Randall, light is central to her work.
When it comes to the kind of light we see outside, of course we want as little of that as possible when we are observing the stars. But the information we receive from the stars, the galaxies, exoplanets and so forth, all of that is also light. For physicists, light is electromagnetic radiation of varying wavelengths. The light that's visible to us with our naked eye is just a small fraction of that electromagnetic spectrum. In other words, in astronomy we are utterly dependent on light. Without light, we quite literally would not be able to see.
Our rather unassuming planetary system is located in the midst of that conglomeration of light. At its center is our Sun, the star whose energy has been powering our planet and the life on it for billions of years.
When we observe the sun, for example, the light that comes from the sun is 8 minutes old. When we observe the oldest galaxies, that light can be as old as the universe itself. That's almost 12 billion years old. So it's very old light. When you consider how big the universe is, how old it is, it's more than a human brain can comprehend.
Alpha Centauri, the star system that is our Sun's closest neighbor, is about 4 light-years or 40 billion kilometers away. But many other stars are not so easy to locate.
We need all of the wavelengths of light to truly understand the universe. It's like when you have a black and white photo. You can see the contours, but a lot of information gets lost. When you only observe the universe in the visible range of light, you miss everything in between. You'll see the stars, but maybe not the surrounding dust. Then you won't understand how those stars were born. That's why we have telescopes that operate at various wavelengths, which allow us to observe the invisible universe.
ESO also has other big plans in store. In 2023, a new super telescope in the high plateaus of Chile is scheduled to go into operation. It will be able to observe light in the visible and infrared range in search of what is called hot matter. But will the light of the universe extinguish one day?
Right now, we have electromagnetic radiation in all wavelengths. But eventually, the stars will die, and then we won't have any more light here on Earth. We still have low-frequency background radiation. The cosmic background radiation we already know. But eventually, light as we know it won't exist in the universe.